Okay, we're at it again. We want to know if this series converges or diverges, and this is the perfect opportunity to use our limit comparison test. When we're looking at this series, the question should be, what does this series remind us of, right? So for large n, for large values of n squared minus 10 over 4n to the fifth plus n cubed, what does that look like? It's essentially going to look like n squared over 4n to the fifth. Why? Because if n is 1 billion, 1 trillion or whatever, then 1 trillion versus 1 trillion minus 10, no, it's irrelevant. In fact, that's what I'll say. Negative 10 is going to be irrelevant. The same with n cubed. And you might be saying, oh, but Kalila, n cubed, that's a pretty big number. No, it's not. Not compared to 4 times n to the fifth power, right? So, I mean, that's going to be n squared. 4n squared, or really n squared times more than the other term. It's really going to be insignificant. That n cubed is going to be, as insignificant as the negative 10 as a constant. It may as well be a constant. Okay, so when n is large, our terms are going to look like n squared over 4n to the fifth, which we can simplify this to be 1 over 4n cubed, right? So this gives us the idea of what we're going to compare, right? So we're going to compare n squared minus 10 over 4n to the fifth plus n cubed with 1 over 4n cubed. Now, let's just look at the limits. So the limit n goes to infinity of n squared minus 10 over 4n to the fifth plus n cubed divided by 1 over 4n cubed equals, okay, so I'm going to do my favorite thing, which is to multiply by 4n cubed on the bottom and on the top. And we'll just have the limit as n goes to infinity. So we'll have n squared minus 10 times 4n cubed divided by 4n to the fifth power plus n cubed. Okay? Now, you could use L'Hopital's rule from here, because this is technically an indeterminate form, right? Because the numerator is going to plus infinity, the denominator is going to plus infinity. However, we actually can cancel some terms out. So let's factor in the denominator, factor out an n cubed. So we'll have n cubed times 4n squared plus 1 in the denominator. And then we'll have n cubed times 4 times n squared minus 10 in the numerator. So those are going to cancel out. So we'll have the limit as n goes to infinity of 4 times n squared minus 10 over 4n squared plus 1. So that's going to be the limit n goes to infinity, 4n squared minus 40 over 4n squared plus 1. And this limit is equal to 1. And you can use L'Hopital's rule repeatedly. You can divide all the terms by n squared. You can compare the dominating terms any way you want to. Just arrive at the fact that your limit is equal to 1. So L is equal to 1, which means these series here both converge or both diverge. And all I have to do to figure out what's going to happen is look at this series over here, because this is a P series with P equals 3. You got it. So this is going to be a P series with P equals 3. So it is going to converge. So since this series converges, our original series converges as well. And that's our final answer.